Now we need to go back into this problem. I didn't even register any of these numbers, and I'm sure I'm not alone in that when I read this out loud to you. So let's go back through and kind of search through numbers. In order to find a slope, we need to have we need points. We need pairs of numbers that go together in order to create these points. So it said at the beginning, Novo Rasco de Opera had only 50 social housing units. Typically time is 0, so I'm assuming that X equals time and Y equals housing. So that's good to keep in mind of what goes with what. At the beginning means that your time is 0. At the very beginning of this, no time has passed. When we first start looking at it, this is the very beginning. So that would be a point that has a time of 0, and then the housing units are 50. Then it says, since then it has been adding new social housing units at a steady rate, now 17 years later. So let's make sure that we keep in mind that time is going to be years. 17 years later, we have 322 social housing units. So now that we've gone back in and found pairs of numbers that go together, we want to make sure we want to go back and find that slope. So we're going to find the difference of our y's, the difference of our x's, and put it into one big fraction. 322 minus 50 over 17 minus 0. Go ahead and tell me what that simplified fraction is. Oops, sorry. It's not a fraction, surprise to me. It is 16, and that's it. Write an equation for the total number of housing units H that the town had in relation to the number of years X that have passed since the social program started. So X is number of years, which we talked about earlier. H is now really our Y, and it says houses. And let's talk about a few things that we have. We have a slope, and we have some points, 0, 50, and 17, 322. Which of the following forms would be the best form to use to make our linear equation? Well, I would normally say our point slope form, because we normally have a point and a slope. We have a very specific point here, which is the y-intercept, right? This 0 value means that we're at the y-axis. So we found the y-intercept. Your b value is right here. It's 50. So mx plus b, here's our m, here's our b. We can just automatically go ahead and create that. So I'll say h equals m, 16, x plus b, 50. E basta. We want to draw the graph of the line representing this equation. I'm really glad that we put this into y-intercept form or into slope-intercept form, because these guys are really easy to graph. We just put that 50 there, and then we can count our slope. Okay, so we have our x and y axis. Let's make our x axis go up by 1. This is years. And let's make these guys go up by, whoops, so sorry. Let's make the y-axis go up by 10s. Okay, so if I wanted to graph my this line, I'm first going to graph my y-intercept. And I could do the slope, which is 16 over 1. Realize that that's a change in y of 16, which means I need to go down 16 or up 16 or down 16, but it would be down and back. So up and over to the right. We would need to go up 16, which would be 56, and then right 1, and then up 16, right? So, or sorry, 66. And then right one. So that's going to be a little bit more difficult. So I'm going to try and think of something that's going to go through crisscross, which will only work if 16 brings us to a whole number. 16, 32, 48, something 4, and then what's 16 times 5? That's 30 plus 50, so that's 80. So I'm going to choose a very special number. I'm going to plug in 5 for my x value because I know that it's going to get me a nice number. I'm being lazy. So if I plug in 5 for x, I get 80, and then plus 50 is 130. So 5 would be 130, which is right here. So it's another nice point. All right. Determine the gradient of a line and interpret its meaning. Well, we've already got our equation in gradient intercept form, so we can just grab it as that number that's in front of x, and the gradient is 16. And interpret its meaning. Remember that that's over 1, and that's the change in y values, and y is houses, over the change in x value, which is years. So that's 16 houses for every year. Determine the y-intercept of the line and interpret its meaning. The y-intercept is our b value, or we could go back here and plug in 0 for x. If we didn't have it in that form, it's always easy to find that y-intercept. The y-intercept is 0, 50. Interpreting its meaning means that at 0, which is our x value is at 0, which means 0 time has passed, there were 50 houses, right? Because 50 is your y value and y is houses. So you're trying to, again, find a comparison of relationships. It's just a little bit of a shift from your slope. It's saying that at time 0, you had 50 houses. At time 0 means at the beginning. At the beginning, there were 50 houses. Hopefully this interpretation piece is starting to get to be normal. This will not be the last time we talk about this. In fact, we talk about it a lot in some of our later units. So just make sure that if this is a part that's confusing you, make sure to star it and say, hey, I need to talk to Megan next time I see her in class. And we need to talk about just interpreting intercepts or interpreting slopes, and we can practice it. Determine how many social housing units the town had 13 years after starting the program. 13 years is our x value. So that means x equals 13, and we want to solve for the number of houses. So what I'm going to do is I'm going to say h equals 16 times 13 plus 50. Go ahead and calculate that for me. You should have gotten 258 houses as your total. Predict the number of social housing units the town will have 22 years after starting the program. State your assumptions. I would like for you to go ahead and calculate the number of houses, and then we'll talk about assumptions. The number of houses you should have gotten is 402 houses. You are plugging in, just like the problem up above, you're plugging in now 22 into your value for x here. Let's take a second and look at at what we've got going on. 22 years is far outside of what we've already graphed. And so 22 is really far into the future. And so by stating your assumptions, you're saying, well, I'm really kind of extrapolating outside of this situation. So we've got interpolation and extrapolation. And we've talked about this a little bit in our statistics unit. Interpolation is when you make assumptions based off of the data that you already see within the realm of the data that you already see. Maybe if I said like 13 would be, it's kind of on the border. But if I said how many houses after 3 years, how many houses after 5 years, that would be interpolation because it's really inside of the number of years that we've already been talking about, versus way out in the future or outside of the data that we've already collected. It's called extrapolation. It's outside of the data that we collected. 22 is definitely an extrapolation, and there's a lot of assumptions that go on with that. Mostly the assumption is that the pattern is going to continue. We are assuming that the number of houses that grow per year stays the same after 20 years, after 22 years. Our assumptions are that the pattern will continue after 22 years. That's a big assumption to make, right? Most of the time, these things don't make it past election times of like whatever officials are there, whether it's in the States or whether it's in Italy. When you change your officials, maybe some new mandates come in, maybe things go to the wayside. So it just really depends. Determine the year in which the town added its 200th social housing unit after the program began. So the 200th social housing unit means that we are trying to find when H equals 200, what does X equal? What is the time? So what we want to do is we want to set this guy equal to 200, our original equation. Go ahead and solve for X. You should have gotten that X equals 9.375, which means that we hit 200 after the 9th year, right? 9.3 means that we've already passed our 9th year and now we are into our next year, which is our 10th year. We haven't completed the 10th year, but we are in the middle of our 10th year. We have completed our 9th year. So then we'll say either after the 9th year or during the 10th year. And it says determine the year in which the town added. So it's after the 9th year, it's in the 10th year. And that's it for our notes today. Good job.